Okay, we are going to solve the problem of finding the kth smallest element in an array. And it's given to us that all of the numbers in the array are unique. So there should be no repeats. And to get started, let's just get kind of a array put up here. Okay, so we've got an array, and let's say k equals 3. In that case, we would be returning 5. Okay, so what we're going to do is actually use a min heap or like a priority queue to put all of the elements in the array into the priority queue, and that way when we dequeue, we only have to dequeue k times, and it will pop off that the kth smallest element, since a priority queue will order it from, if we're going top up, from biggest to smallest. So the smallest elements will be at the beginning of the queue. So let's go ahead and code it. We'll be returning that element. Okay, and we need to pass in the array, and we need to know k. All right, so first off, we want to put in some basic checks on our array. So if array.length is 0, then we want to throw an exception with some sort of message about the array not being, or the array being empty or null, something like that. Okay, else if array.length is less than k, we also want to throw an exception and give some message that the array is smaller than k, because it would then be impossible to find the kth smallest if there aren't enough elements. And then we might want to do a check on if k is less than 1, because if it's 0 or a negative number, we wouldn't really be able to find the kth smallest element. So if k is less than 1, we can throw an exception as well, letting us know that the k is invalid or too small. Otherwise, we can go in to our algorithm. So first we're going to make some variables. We need to store the kth smallest element. For now, we'll just set it to 0. And then we also need, not an int, 1 sec. We also need to set up our priority queue. And it's of ints. We'll just call it PQ. And if we're using Java has a built-in priority queue, but C# does not. But you can just put in a NuGet package to be able to use that functionality. There are tons of them that have been written and are optimized. So we'll go in, and the first thing we want to do is go through each element in the array. So for each array, and then we just want to add them to the queue. Okay. Then our next loop is going to be a partial loop. So it won't go through the entire array unless k is equal to the length of the array. So I equals 0, I is less than k, I plus plus. And we would pk dot dequeue. And actually, we would want to set the kth smallest is equal to that. And we'll go through the whole array like that. And then once you've gone through, the kth smallest will be the last one that pops out of the queue. So that would be correct there. And then we would return the kth smallest. And we're done with our function. That's for the else statement. Here's for my entire function. Okay, so let's test this out. We will make a queue. We've got I to keep track of, and we have our queue, and we have the kth smallest. Okay. So first we come in, and if array.length equals 0, which it doesn't, so we will keep going, else if array.length is less than k, which it's not, else if k is less than 1, which it's not, else we have int smallest, it's going to start at 0, and we've got our priority queue made up. So first we're going to go through each element in the array and throw it into the queue. So it will start here, it'll start at 4, and throw that into the queue. And then it will loop back through and go to 3. It'll put that in the queue above the 4. And loop back through, we get to 7, and 7's gonna go below the 4. And we loop back through, we get to 5. 5's gonna go between the 4 and the 7. Loop back through, we get a 10. That's gonna go below the 7. Loop back through, we get a 15. That goes below the 10, and loop back through, and 20 would be at the end. Okay, now we're going to go through our next for loop that goes k number of times and dequeue. So I starts at 0, I is less than k because k is 3, and the kth smallest equals pk dequeue. So first it's going to go and it's going to give us 3. And then we go through I++, and I is 1, and that's less than 3. So we dequeue again, and it pops off a 4. So that's gone. And then we go I++, 2 is less than 3. So we go into our loop, and we pop off the next element in the queue, and that is 5. Then I++, 3 is not less than 3, so we break out of our for loop and we return kth smallest, which is 5. And the complexity of this algorithm is n for the for each loop, because it has to go around the entire array, plus O of k log n. Because we aren't going a full n, we're just going the k number of times. And so that is the big O, because whenever you dequeue, it is a login operation, or an n login, depending on if you're doing an entire array, but it's login. So that is it, and it should function just as we're asking it to.